So, welcome. So, today I will talk about a historical background of gravitational force, that how idea of gravitational force came into the mind of Isaac Newton, and I will also talk about that a brief introduction to Kepler's laws, because after Kepler's Isaac Newton has given the this law. So it's basically a inverse square law type force. So let me briefly go through. Okay. So ऐसा क्या हुआ जिसने न्यूटन को एक लॉ देने के लिए मोटिवेट किया? व्हाट मोटिवेटेड न्यूटन टू गिव द लॉ ऑफ ग्रेविटेशन? So before Newton, there are certain existing laws, and those laws are the Kepler's laws of the planetary motion. Right. So what Kepler's laws tells us about? Kepler's laws tells us about that motion of planets around the sun, and these laws provided us the mathematical description of planetary orbit. But there is one problem with this, that these laws couldn't explain that why planets move in that way, because planets move around the sun, but why those planets will move around the sun? There is no explanation for that, right? Means basically he has given these laws on the basis of certain experimental or certain experiments. Then what Newton did, Newton basically uh, has given the cause behind that, कि वो लॉज सॉरी वो प्लैनेट्स कैसे उस तरह से रिवॉल्व करते हैं, या कोई हेवनली बॉडी क्यों उस तरह से रिवॉल्व कर रही है या मूव कर रही है इन स्पेस, राइट? देन so before moving towards the Newton and the Kepler, let me talk about briefly that the era before the Kepler, right? There is a person Tycho Brahe, and he devised and used most accurate pre-telescopic astronomical instruments. Means he didn't use telescopes, and Tycho Brahe is a very good observer, और उन्होंने बहुत सारे एक्सपेरिमेंट्स किए, ऑब्जर्वेशंस ली प्लैनेट्स के बारे में और स्टार्स के बारे में, एंड but Tycho Brahe again attached to the earth-centered model. Say here, see this one. This is earth, right? And sun is also revolving around the earth according to him, according to his model. Even the moon is also revolving around it, right? But later on his and yeah, according to Tychonic system, or according to Tycho Brahe, that means this is a Tychonic system. So here this sphere means our planets are surrounded by the stars. These are the stars, and the moon and the sun are shown orbiting the earth. So this is a sun, and this is a moon, so it is orbiting around the earth. Sorry, this is sun, and say this is moon, and this is earth. So this moon is orbiting the earth, and even the sun is also orbiting the earth. And but other 5 planets, this is one planet, 1 2 3 4, these are the other planets, and there is another planet on this orbit which is not visible here. It means other 5 planets are also orbiting the sun. So this was little bit different than the sun-centered model proposed by the Copernicus. What here, earth is also revolving around the sun, right? So that's what is going on now. Let me, but lots of data is there, and his student say Kepler, he dealt with that data और try to see that look at that data. So जब उन्होंने उस डाटा को देखा तो उसके बेसिस पे उन्होंने कुछ और conclusions draw किए. So that because Kepler is a student of Tycho Brahe, so he utilized the Brahe's data. In particular, Brahe compiled extensive data on planets, Mars, which would later prove crucial to Kepler in his formulation of the laws of planetary motion, because it would be sufficiently precise to determine that orbit Mars was not a circle but a ellipse. This is the main conclusion which he draw. So Kepler is a very good mathematician, very good astronomer, and became the Brahe's assistant. And after Brahe's death, Kepler gained the access to his invaluable observational data, and he discovered Kepler's laws. So he formulated 3 laws. So there is a first law. This is a very interesting law, that the planets not move around the, say, as suggested by Tycho Brahe, because what Tycho Brahe suggested that 5 planets move around this one, and other planets, say sun is revolving around the earth. This was suggested by Tycho Brahe, but he carefully observed that data, and after observing that data he has given 3 laws. So first is planet move in a elliptical orbit with the sun at one focus. So that means if it is sun, then say planets move around in this way in an elliptical orbit. So this was suggested by Kepler. This is the first law. And what is second law? The second law is that it's a law of equal areas. And what was it? What is law of equal areas? Let me go talk about it. Say this is elliptical path and say sun is here. So say at any time planet will be here at this point. This is one planet, and after some time planet will reaches at this point. So say it has taken delta t time to reaches from here to here. So that means this sweeps out certain area, and let us say this delta A is the area swept by this planet when it is moving from this point A to B. And similarly, at some time it was here, say at point C, and after that it moves at time D, and in the same time, if it will take same time from reaching from C to D, then both the area swept by this planet will be same. So that means, say here it is away from the sun and it will sweep out the area delta A, and when it is more closer to the sun it will also sweep the area, but these two areas must be equal. And this is possible if and only if it will moves faster here and it moves slower here, right? So this is the law which was given by this what we call this is the law of equal areas. Then another very interesting law, that the square of the planet's orbital period is proportional to cube of the semi-major axis. It's a cube of the semi-major axis. So say semi-major axis is, say it is A. Then this is Newton's third law. So what is major axis? Say it is the sun, so it is semi-major axis. So this time is proportional to, means when it completes one revolution, then it is proportional, its square is proportional to AQ. This is the Kepler's second law. Then Kepler's empirical framework to the Newton's framework. Let me talk about it. So, so what is Kepler's first law? Was a groundbreaking discovery. He didn't derive it through formal mathematical proof, but trial and error methods. Kepler meticulously analyzed Tycho Brahe's observations, and he tried to fitting the data to the various models, including circles, epicycles, geocentric model, and intuitive leaps. Through a combination of careful observation, meticulous calculation, and likely some intuitive leaps, Kepler realized that elliptical shape provided the best fit to the Mars orbit. But there is a lack of mathematical derivation. So Kepler couldn't formally prove that elliptical orbits were the only possible orbits under the influence of the central force. Then let me talk about Newton's contribution. Newton, with his law of motion and law of universal gravitation, proved the theoretical framework to derive Kepler's first law mathematically. And Newton showed that under the influence of an inverse square force like gravity, the only possible orbits are the conic section. Means you talk about every possibility. There are certain bodies which moves in the circle, and there are certain bodies which moves in ellipses, and there are certain which moves in parabola, and which moves in, and others moves in the hyperbolas. So Kepler's empirical discovery of the elliptical orbit was then explained and justified within Newton's more comprehensive framework. So let me talk about Newton's law of gravitation. So before moving towards the Newton's law of gravitation, मैं सबसे पहले बात करूंगा मोशन अकॉर्डिंग टू अरिस्टोटल. और उससे पहले जो हम मोशन को कंसीडर करते थे, तो मोशन दो तरह का था. पहला था नेचुरल मोशन. मीन्स फॉर एग्जांपल जितनी भी चीजें पृथ्वी पे अर्थ पे हो रही थी, उनका मोशन कैसा होगा? देयर मोशन इज अ स्टेट. मीन्स इफ आई थ्रो समथिंग अपवर्ड, वो ऊपर जाएगी एंड देन विल अगेन कम डाउन. तो इसको हम बोलते थे टेरेस्ट्रियल लॉस. देन एक और था नेचुरल मोशन में, फॉर अ सेलेस्टियल ऑब्जेक्ट का जो मोशन था, दैट वाज सपोज्ड टू बी सर्कुलर, राइट. फॉर एग्जांपल ऐसा माना जाता था कि जितनी भी चीजें हैं, अगर प्लैनेट्स हैं, तो वो प्लैनेट्स क्या करें, दोज प्लैनेट्स आर रिवॉल्विंग अराउंड द सन. जैसे पृथ्वी है, अर्थ है, वो क्या कर रही है? वो एक जियोसेंट्रिक. सो कोई भी चीज है, वो क्या कर रही, वो पृथ्वी के चारों ओर चक्कर लगा रही थी, जैसा हमें दिखता है. जैसे सूरज है, सूरज पहले ईस्ट से निकलता है और शाम को वेस्ट में जाके छुप जाता है. वैसा ही मोशन मून का है. ऐसा ही हमें डिफरेंट जो कॉन्स्टिलेशंस हैं हमारे पास, जैसे ओरियन कॉन्स्टिलेशन है, वो भी कुछ उसी तरह का चक्कर लगा रही है. तो ऐसा लगता था कि जितनी भी चीजें हैं उनका मोशन कैसा है? सर्कुलर है. इट सीम्स लाइक दैट. देन दूसरी टाइप का मोशन था वायलेंट मोशन. बोलते हैं हम किसी चीज को पुश कर रहे हैं, पुल कर रहे हैं, तो उनका जो मोशन होगा दैट इज अ वायलेंट मोशन, उसको हम बोलते हैं. वायलेंट मीन्स वी आर इम्पोजिंग दैट मोशन. हम खुद कर रहे हैं, उस मोशन को हम इम्पोज कर रहे हैं. ठीक है. सो ये दो तरह के मोशन जो हमारे पास थे. बट देन न्यूटन केम. मीन्स देयर आर टू टाइप्स ऑफ मोशंस. और अदरवाइज इफ यू टॉक अबाउट दैट, देयर इज अ टू टाइप्स ऑफ लॉज. टेरेस्ट्रियल मोशन के लिए टेरेस्ट्रियल लॉज थे, एंड द कॉस्मिक लॉज थे सेलेस्टियल ऑब्जेक्ट्स के लिए. So that means that our nature is governed by two different types of laws. Before Newton, और जो अरिस्टोटल ने हमें conclusions दिए according to Aristotle. Now let us go to the Newton, Isaac Newton. So it was known to all that Newton was sitting under an apple tree, and suddenly apple falls. Then Newton asked to himself, what pulls apples from the tree? It's a very interesting question. He asked with himself. And and all of us know that this question, that एप्पल जो है वो नीचे क्यों आ रहा था, ये न्यूटन एक और क्वेश्चन पूछा. बट इसके साथ ही न्यूटन ने एक और बड़ा इंटरेस्टिंग क्वेश्चन पूछा कि क्या ये फोर्स सेम है जो मून को भी अर्थ के चारों ओर चक्कर लगवा रही है. तो से ये अर्थ है और ये ट्री था, यहां से एप्पल नीचे आ रहा था, और वही मून जब यहां पे है, मून अगर यहां पे है तो ये मून इसके चारों ओर चक्कर लगा रहा है. इट इज ऑर्बिटिंग अराउंड द अर्थ. सो दैट मीन्स इज द फोर्स सेम? This is the second question which he asked. We will talk about this question very rarely. We can see only this thing in the mostly textbooks, but this is missing. So that means there is a possible answer. जो force of gravity है, that might account for the motion of planets. Right? This is a possible answer. Another is force on each planet would be directed towards a fixed central point. Or towards the sun. So that means the concept of central force will come out. Because it is towards the center of something. So what he did? So earlier when apple is falling from a tree, then it is a natural motion. And the sun, when the moon is revolving around the sun, then it is a celestial motion. Then both the motions are different. But now what he did? He tried to relate the both, the motion on the earth and motion around the earth of something. Means Newton tried to say unifying both celestial and the terrestrial motions. So that means this falling of apple from the tree, और जो क्वेश्चन न्यूटन ने अपने आप से पूछे, उन्होंने क्या किया? They try to unify terrestrial laws and the cosmic laws, and this is called the Newtonian synthesis. This I have taken from this book, Paul G. Havel. So that means, see, if I look at this particular point, that the force on each planet would be directed towards a fixed central point, towards the sun. So that means we are talking about the central force. Means there is a force which is acting towards the center. So let me talk about here the concept of central force. The concept of central force is associated with the Isaac Newton. And central force is a force that always acts along the line connecting the object experiencing a force. Say, this is sun. Say, this is earth. And earth is revolving around the sun in this space pose. So when it is here, then it is experiencing a force towards like this. And when earth will be here, then it is again experiencing a force towards the center. And there are various examples of the central force. One is the gravitational force. So Newton's law of gravitation describe a classic example of a central force. And gravitational force between the sun and the planet always act along the line connecting sun and the planet. And there is another force, that is electrostatic force. And the force between two charged particles is also a central force and acting along the line connecting the charges. Right. So this is it for today. So today I will talk about that. I will talk about say Tycho Brahe and the things goes to the Kepler, and Kepler has derived certain laws on the basis of empirically on the basis of the data available to him by Tycho Brahe. And then Aristotelian view of the motion, that there are two types of motions, terrestrial and the celestial motion. And then apple falling from a tree, and the question asked by Newton by himself helped to connect both the terrestrial and the celestial motions, right? And the idea of concept of or the idea of central force will come out, right? So that's all for today's lecture.